All right, so in the last video, I talked about how I went to the NANDA AI Summit over in Cambridge. And while I was there, I had gotten accepted to, well, I got introduced to basically the largest AI hacker club in the area called Sunday. And then I went back home to Florida, applied, got accepted for their next Sunday hack. And so this is going to be the story of how I went back to Boston, all the adventures I had at this AI club, because the whole idea for me was that by like going to this community, I would be able to like immerse myself in the broader AI space in Boston, Cambridge, and hopefully have a path to a startup. I was a bit skeptical as to whether this would really work out because the thing about hackathons is that a lot of times they tend to attract people who are just interested in building, while the people who are actually getting things done aren't spending their weekends at like any kind of AI clubs. They're like busy deploying, dealing with friction. That, and also the fact that basically the whole idea of this club is that they meet every Sunday and they have a theme. So sometimes it might be voice agents, sometimes it might be local models, sometimes it might be OpenClaw, whatever. Basically, they spend the whole day building some kind of project around the theme, and you have to have something finished and ready by 8 p.m., which sounds very intense. And the thing is, like, it's very hard to like actually build anything useful in such a short amount of time. I mean, you may be able to build something that looks cool and can demo well, but that's not the same as actually solving a problem that people need. That said, this did look like a pretty cool and promising opportunity. So, you see, my rent was going to expire that month anyways. So basically, I just had to book a one-way flight, put my things into storage, find a place for my car, like all of the moving stuff. It's quite, it was like, it was a very short time frame because again, like I had like 10 days, to get to Boston from when I received the invitation. There was actually a funny anecdote because you see, I had learned about Sunday while in an elevator with one of the main organizers back at the NANDA Summit event. I met him 4 weeks later at a Boston University presentation. He said, like, "Oh, hey, you're still here. I thought you lived in Florida." I said, "Yeah, I did live in Florida. Now I moved down here 2 weeks ago because of the Sunday club you introduced me to." Overall, the travel was fairly uneventful. I flew on Saturday, and so my first Sunday hack would be the following day. The theme for the first hack was a project called ZeroClaw, which is basically an alternative to OpenClaw that's much smaller because it's written in Rust, supposedly much more performant and better written. I didn't build anything like too spectacular. It was basically there was a framework that for autonomous companies called MetaGPT, and I changed it to use ZeroClaw agents rather than just standard like bare LLM agents. Overall, it went a bit different than I expected. It wasn't quite that intense. It was actually more like a lounge, basically, where the broader AI community in the area just go there to, explore things, prototype, experiment, discuss like industry trends. The day starts off with coffee and some AI news. It all ends with presentations at 8 p.m. All right, now that said, so I was in Boston. My goal was to basically try to find an opportunity for a startup and like some kind of promising solution for it, so I could actually start like working on something, collaborating with some people, actually like get to development. Now the thing is, so like I had Sunday, that was like a good networking tool, a good prototyping space. But that said, like in order to actually begin with a startup, you need to have an actual like problem that you know well enough and that you have a promising solution for. That's not necessarily going to come out of any kind of AI group. And so the first thing that I grappled with really was like, okay, what should I be spending my time on? I mean, like there's lots of different activities you could do. I could focus on just inviting as many people that I meet out for like discussions and trying to like talk to as many people as possible about what kind of problems they deal with, what they think about these broader industry trends. I could spend my time reading papers. I could spend my time just building and prototyping, experimenting at home. I could spend my time like contributing to open source software like Nanda. Um, and if I do decide to go along the route of talking to as many people as possible, should those be over Zoom? Should they be cold emails? Should they be like physically going out for coffee? It was like there's lots of things you could do. And what I eventually settled on was that like there's not just one thing to do exclusively. The way I see it is kind of like I could compare it to like a video game where you have a toolkit of actions, and the aim of the game is to use each tool where it makes sense. And so like talking to people, especially when you need to like find some kind of opportunity, some kind of problem solve, that's good, but it shouldn't take the form of like just randomly, haphazardly invite everybody you meet out for coffee. Because if you invite people who are in a completely different, like let's say they're in pharma and deploying AI in pharma, and you've never worked in that industry, then you might end up just wasting both of your time. Reading papers is good, but only if it's a paper that shows some kind of like promising solution for a problem that you're already obsessed with. So the actual like project or idea that I settled on was I wanted to explore how we could use alternative machine learning architectures for agents. For me, like I had listened to Jan LeCun on Lex Friedman's podcast the year previously where he talked about his JEPA models, and that architecture seemed really interesting to me because I always thought that the idea of using a text generator as an agent was a bit of a hack. Like an agent, you want to have world modeling, you want to have prediction, you want to have planning, and there were theoretical advantages that a JEPA model would have for that. And so what I ended up doing was having some doing some like prompting with Claude and taking a look at how we could implement JEPA models into the domain that I'm in, software engineering. I figured it's probably better to stick to my own domain because that's what I'm going to understand best. What I thought was that the JEPA model, which in theory would be better for planning, for reasoning, and for world modeling and for predictions, that could be like a manager or an orchestrator to a downstream LLM that actually does the code generation and the token prediction. So the idea was that I would use both architectures where they made the most sense. And so this is what I ended up exploring on the Next Sunday Hack. I found two other people who were interested in this kind of idea, and so we spent the whole day, just whiteboarding, discussing, prototyping, vibe coding. In the end, I think we had a pretty decent project out. Spend a few hours right now basically just trying to play with these JEPA models and understand like how we can encode the state of a software system world model, because like an LLM, it'll store really just the like code files, just the content of your source code files. But we know that that's not exactly the same as a like entire software system state. In the software system state, it contains things like the contents of the database, the contents of the computer's memory, the results of web pages in the browser, how the state of the pages in the browser. It contains things like the result of workflows that you do, like, okay, you click on this and then this behavior happens. So the state of behaviors and workflows. And so actually I'm finding that there's some things that their LLMs are actually pretty good at. So for example, if you don't want Google to index certain pages on a website, then you put them into robots.txt. But the thing is, that's something that we're like a world model that truly encodes the state of everything that's relevant to that would have to encode the state of robots.txt, the state of like actually calling Google's APIs and reading out exactly which pages are indexed. Whereas an LLM, it simply, just based on its higher level text understanding, it understands that robots.txt does something called prevents something called indexing, and
that's really like it doesn't like all that extra state is probably irrelevant for that. So maybe the system is going to need some kind of like router that decides whether to route it to an LLM or to a JEPA model. Like,
The problem is that few in the coming weeks, when I really looked more into JEPA models and tried to actually implement this, what I realized is that during that hack, I had completely like misunderstood what JEPA actually does. Um, it's not that like JEPA models have a world model and LLMs don't, and that JEPA models can do prediction and LLMs can't. No, JEPA does its prediction in latent space and doesn't generate anything. But for any kind of like code, you need to obviously have a text generator, a token generator, an output, which was supposed to be the LLM. But then in that case, that sort of just moves the problem, where now you need to find a way to map from JEPA's latent space into an LLM's latent space, and at that point, you just have an LLM. And then the other thing I realized is that JEPA, LLM, like while I was working, I noticed that whenever I put my like stuff up for code review to an LLM, to GitHub Copilot, it would like identify downstream bugs that were going to happen and stuff that like all of my teammates had missed. So, I mean, that is a world model that is doing predictions in a world model. I mean, we don't know exactly how it works under the hood, but at the end of the day, the emergent behavior is predictive world modeling in a sense. So if LLMs are a very good way to do to work in token space, why would we expect a JEPA model to do better than that when like tokens are already a very compressed like good format for code? I mean, it doesn't really get much more abstract. I mean, you can get more abstract than that, but tokens are probably about as abstract as you need for coding tasks. And then there's also the fact that like training up a frontier JEPA model, that would be, it would cost, that would be an astronomical cost. But now the thing is that did lead to another idea, which was LLMs. So one thing that they're not good at is debugging complex multimodal bugs. So like let's say a commit over here affects like a AWS service here, or a container here, or a microservice here. Like those bugs where you have the database, the operating system, the code, the services, a lot of like complex interactions between services. What I thought was that, okay, what if we take like the entire software ecosystem of an entire organization, encode that into a like giant comprehensive graph, and then feed that into as the context into a frontier LLM. So that's what I tried on the next hack, and what I quickly ran into was it's very hard to encode everything into a graph, and even if you could, that graph is obviously going to exhaust immediately all the context of even LLMs with the heaviest context windows. So you need a like way to search in that space. And then the other thing I realized is that like the word software ecosystem, it's really like, what is it? It's the AWS services, it's the source code of the repositories. Okay, it's the database, but an agent can already get context from all those sources. They can use like SDKs to get information from like different cloud providers you have. They can run queries against the database, like read-only ones. They can read your source code files. So at the end of the day, like, yeah, we already kind of have this. Although one thing that I actually just thought about while making this video was, maybe if we had more efficient vector databases that could like better grab the right context that you need. But I think that's irrelevant for right now, because what I was realizing by this time was that I was trying out way too many like fancy solutions to problems that like I hadn't personally encountered myself. Like I needed to actually get some real data on the ground of where do agents really fail in software development. and then I could try like targeted solutions towards those problems. So like what I started doing in the coming weeks and what I still currently do right now is try to like document everything that I do at work as meticulously as possible, like, writing detailed logs of exactly how I solve specific bugs, the things that I tried, and what the actual solution was in the end, and where an agent either did or would have gone wrong. So things like, okay, maybe to solve this, what I needed to remember this like thing that happened 3 weeks ago, and so that's episodic recall. For this, maybe I needed to get all of this context, and the reason the agent couldn't do it at first is because it didn't have that like skill. And so I was trying to get like more concrete, like real data points for these problems. Now, the way I first used this information was I decided I'm going to try to automate everything and be like a fully autonomous software engineer agent. Now, I've currently moved away from that because I don't think that even if you could do that, which is very unlikely for reasons I'll get into, but even if you could, all it really does is now you have to review all of that work, which often takes up more time than just having actually like written all the code and everything, done all the setup yourself. I think it's probably more useful to deploy these things in terms of getting better answers to specific questions from developers, or identifying root causes of bugs, things that you can like validate very quickly, but that are very time consuming to get that information. Now, so far, the way this has gone is that all of the solutions, all of the like things that I've come up with aren't anything like radical that you could actually commercialize. So one of the things is, for example, a prompt that forces agents to think in a more like scientific method sort of way, where they have a model of how the system should work, what's not working, what information do they need, and testing hypotheses against that world model. So which is kind of how most like senior engineers actually think. They think, okay, like, why this bug is occurring? What is the actual, like, how would I expect the state of the system to be? At which point is it failing? Let me try different things in those spaces. But that's just a prompt. Like, you can't commercialize that. I mean, that's like a GIS that you just put publicly. Another thing is, for example, using Google searches for certain problems, because they may not always have like the actual problem itself in memory. Like sometimes you need to go to the GitHub issues page to find out how to solve something. And apparently, like, for example, GitHub Copilot doesn't do that. There's a lot of like things that an agentic engineer in 2026 has. I mean, we can put skills into our agents. We can edit the prompt. We can build MCP servers. We can like use vector databases for persistent memory. There's lots of things. Now, the thing is, the way that's gone so far is that, like, as I said, the solutions that I've come up with so far are either stuff that you wouldn't commercialize as just like small skills or quick fixes, or it's stuff that's very specific to a certain workflow that you can't really generalize to like organizations in general. Like, you can't build a better agent. It's just you found a fix for you found something that only applies to a specific workflow. Now, one thing is that I'm getting very skeptical of this approach as well, because for one, this is basically competing with like OpenAI Codex or Anthropic's Claude Code. I mean, these are like frontier labs, have the resources to like really build better agents. An individual person is probably not going to come across anything like substantial. And the other thing is that most developers, they tend to use like open source software. So if you're going to be offering like a better agent, it had better be like 10 times better than what's already out there, because most developers will just default to open source tools. At that point, after about 7 weeks in Boston, doing all these various things that I had described, I decided to move back to Florida because I felt like the Sundays weren't really giving me anything. Like, I had already a workflow that I was going down. All of the like research that I had done into JEPA and context graphs and memory and whatever, that had all been done by just me reading papers. So like Sunday wasn't really providing me anything that I would need to be there for. Although I still stick with I still like go to their Discord meetings, their online Discord meetings weekly. And the other thing is like, Boston is a very expensive city. It would have been about $1,500 extra per month to live there, which I think is kind of a waste of money. So I ended up moving back to Florida, and that's where I currently am. And I still try to stay in touch with all the AI news, although I'm not sure if I'll really stick with agentic AI for much longer, unless I find something promising here. Because I mean, I didn't actually like find anything that would be actionable that I could like get to work solving.